In this lesson, we're going to be talking about proportional tables and equations. This example here is going to launch us into this lesson today. So let's take a look at the left-hand side of this example. You can see that we have a proportion, which is again two ratios that are equal to one another. Notice how the numerators are my y coordinates and my denominator is my x's. So we're going to be talking about this, but let's go ahead and place these numbers into our table of values, meaning we're going to go ahead and we're going to place our y's in the y position and our x in the x position. So you can see here that my y's are going to be 6 and 10, and my corresponding x values are going to be 3 and 5. Now, what I want you to take from this right here is that whenever you have a table of values, if you look from the x's to the y's, you have this thing called a multiplier. This multiplier is going to be also called your slope or your rate of change. And we're going to be talking about those vocabulary words as the lesson goes on. But you can see here that 3 times 2 is going to leave us with a 6, and 5 times 2 is going to leave us with a 10. So our multiplier in this case is going to be 2. What this is going to do is going to lead us into a proportional equation. And a proportional equation is in the form y equals our multiplier times x. So in our case, our multiplier is going to be 2. So our equation will be y is equal to 2x. Now that's kind of going to launch us into what we're going to talk about now. Now I know this page has a lot of writing on it, but I just want to kind of explain what this is all about. So at the top it says, when two quantities, x and y, vary in such a way that one of them is a constant multiple of the other, the two quantities are proportional. You're going to be hearing that word quite a bit this unit. A proportional equation, just like I said before, is of the form y equals mx. Now, this variable m represents that multiple or that slope or that rate of change, we like to call it. Sometimes in math, one little piece of an equation will have multiple names. So if you hear me say slope or rate of change, that's what it means. It means that it's going to represent this variable in the equation. Now let's look here below. The ordered pairs 4, 2, and 6, 3 make up 2 points in a proportional relationship, y equals mx. So what I did here was I took those 2 coordinates and I placed them into a table of values. Remember, when I have a coordinate, my first coordinate is always going to be my x and my second is going to be my y. So here I'll go ahead and indicate that. So all I did was place them in my table of values to the left. Now, let's talk about this concept of a unit rate. The unit rate, or the slope, or the rate of change. See what I did there? I added another name for slope and rate of change. They all mean the same thing. Here is what it means when it comes to a proportional relationship. When I have a proportional relationship, I have a ratio y divided by x. When I divided by y by x, in this example, you can see that my y divided by x would be 2 divided by 4. Do you see my 2 and my 4? I also have my 3 divided by 6. 3 divided by 6. If I were to simplify these ratios, they would simplify down to 1/2. This right here in this box is called my slope. It is called my rate of change. It is called my unit rate. They all mean the same thing, and they represent the m in the proportional equation y equals mx. So, with all this said, the equation of a line representing this proportional relationship of y to x would be what I have here below. Y is equal to 1/2 x. Okay, that was kind of an explanation. Now let's go ahead and try one to see if we can apply this concept. So here we have 2 given coordinates. These coordinates would go on a coordinate plane. Now let's go ahead and fill them into our table. Remember, our first coordinate is going to be an x, and then our second is going to be a y. So I'm going to go ahead and indicate them. I'm going to go ahead and fill in the table now. My x is 4, my y is 8 for the first coordinate. My x is 7, and my y is 14 for the second coordinate. Now I'm going to go ahead and determine the unit rate, or again, we have the same names, unit rate, slope, and rate of change. They all mean the same thing. And I want to divide the y-coordinate by my x. So I'm going to go ahead and divide my 8 divided by my 4. And I'm going to go ahead and divide my 14 divided by 7. Either way I look at this, 8 divided by 4 is going to give me 1/2. I'm sorry, it's going to give me 2. And 14 divided by 7 is going to give me 2 as well. So I'm going to indicate that by saying 2 over 1. Let me go ahead and back up and kind of show you how I did that. If I look at my first ratio here, 4 goes into 8 twice, and 4 goes into 4 once, giving me that 2 over 1. 7 goes into 14 twice, and 7 goes into 7 once, giving me that same ratio of 2 over 1. Now that I have that ratio, I can go ahead and create my proportional equation. So I'm going to rewrite it as y is equal to 2x. Now you might be wondering, why did I write just a 2? Because if you remember earlier on, we can simplify this down to 2. Because when you simplify a fraction, it has to be in simplest form. So therefore, my proportional relationship will be y equals 2x. Let's try another one. Let's go ahead and fill in my table of values. So I have my 18, 6, and I have 12 and 4. Now I'm going to go ahead and determine the unit rate from my table. I'm going to take my y and divide it by my x. So my y divided by my x, and then my y divided by my x. Now, if I go ahead and I look at these individually, I can simplify them. 6 goes into 6 once, and 6 goes into 18 3 times. 4 goes into 4 once, 4 goes into 12 3 times, simplifying this down to 1/3. Now, 1/3 cannot be simplified down to 3 because it's a fraction. It's just 1/3. So my proportional relationship or my proportional equation will be y equals my slope, which is 1/3, with an x. And I'm done. Now let's go ahead and do 2 more examples, and let's create a proportion, a table of values, figure out the slope, and then figure out the equation. So my proportion, remember, all of my proportions are going to start with y divided by x. And let's figure out what they are. My first one is going to be, remember, I'm going to label this xy and xy, and I'm just going to go ahead and pop them into place. 9 divided by 3 and 12 divided by 4. That's my proportion. We can actually say that this is equal to them. The table of values, let's go ahead and do that now. I have my 3, I have my 9, I have my 4, I have my 12. Now, to figure out my slope or rate of change, I need to simplify. So I'm going to go ahead and simplify this proportion down. I can simplify this down to 3 over 1, which of course simplifies down to 3. We could also look at the table of values and say, well, if I'm trying to figure out the multiplier between the two, the multiplier is going to be times 3, because 4 times 3 is 12, and 3 times 3 is going to give me 9. So that means that my slope, or my variable m, is equal to 3, which means that my proportional equation will be y is equal to 3x. Try another one of those. My proportion in this next one, let's go ahead and label my points xy and xy. And let's go ahead and write my proportion. I have y over x, which will be 30 divided by 6 is equal to 15 divided by 3. Now, if I were to simplify these both down, that would simplify down to 5 over 1, which of course would simplify down to 5. If I look at my table of values, oh, and by the way, the proportion, this right here is my slope. My table of values, let's go ahead and put my numbers in. I have 6 and 30, and I have 3 and 15. My multiplier between the two numbers is times 5. So therefore, my slope is equal to 5. And I'm representing slope by the variable m because that is the variable that is representing slope. And then if I were to write my proportional equation, I would write y equals my slope times x. And I'm done. All right, that brings us to the end of our lesson on proportional equations and tables.